Beneath the waves lie forgotten cities, bustling ports, and entire villages lost to time. For centuries, these were just myths and legends. Today, we're finding them. How? Not with treasure maps, but with sound waves, robots, and artificial intelligence. Welcome to Fun Facts Online, where today we're diving deep into the incredible world of modern marine archaeology. The first question is, how do you even begin to search the vast, murky ocean floor? You have to listen. Archaeologists use sonar, which is short for sound navigation and ranging. Think of it as painting a picture of the seabed using sound. One type, side-scan sonar, is towed behind a boat and sends out fan-shaped sound pulses. It creates a detailed, almost photographic image based on the echoes. Hard objects, like stone walls, produce strong echoes and appear as light areas, while softer materials like sand and mud appear darker. Crucially, objects that protrude from the seabed cast acoustic shadows, dark shapes that reveal the height and form of a potential target. But that's just a 2D picture. To see the landscape in 3D, you need multi-beam sonar. This sends out hundreds of narrow beams at once, creating a high-resolution topographic map. Suddenly, you're not just seeing a bump on the sea floor. You're seeing the precise layout of a building or a collapsed harbor. But what if a city is completely buried under centuries of mud? For that, archaeologists have a tool that's like having X-ray vision, the sub-bottom profiler. It uses low-frequency sound waves that can penetrate through layers of sediment, revealing structures hidden completely out of sight. Alongside sound, archaeologists also hunt for magnetism. A marine magnetometer is an incredibly sensitive sensor that measures minute variations in the Earth's magnetic field. A large concentration of iron, such as a ship's cannons, anchors, or even the iron fasteners used in its construction, will create a detectable disturbance, even if buried deep in the mud. Together, these remote sensing technologies turn a seemingly featureless expanse of water into a map of possibilities, dotted with the ghostly outlines of history. Once you have a promising spot on your map, it's time to get a closer look. But we're often talking about depths no human diver can safely reach. Enter the robotic pioneers. First are the ROVs, or remotely operated vehicles. These are unmanned, tethered submersibles controlled by a pilot on a surface vessel. They are the workhorses of deep-sea archaeology, serving as the eyes and hands of the exploration team. Equipped with high-definition cameras, powerful lights, and manipulator arms, ROVs can fly over a submerged city, gently clearing away sediment and retrieving artifacts, all while staying on site for far longer than any human could. Then you have their autonomous cousins, the AUVs, or autonomous underwater vehicles. These are the scouts. AUVs are untethered and operate independently, following a pre-programmed survey route. They can efficiently map vast areas of the seabed with their own sonar and magnetometers, gathering high-resolution data that guides the more focused work of the ROVs and divers. This combination of sonar mapping and robotic investigation led to one of the most spectacular discoveries of the 21st century. For centuries, ancient texts spoke of a legendary Egyptian port city, Thonis, also known by its Greek name, Heracleion. It was thought to be a myth until the year 2000. A team led by French archaeologist Franck Goddio, using a systematic survey with magnetometers and sonar, found something incredible beneath the waters of Abu Qir Bay. It wasn't two cities, but one magnificent metropolis. The definitive proof was a stunning black stone slab, a stele, which was inscribed with a decree stating it should be placed in the city of Thonis. Yet it was found in the great temple of Heracleion, proving the two were one and the same. Subsequent excavations by divers and ROVs have revealed a city frozen in time. They have uncovered colossal, 5-meter-high statues of pharaohs, queens, and gods, the remains of more than 75 shipwrecks, over 700 ancient anchors, and a treasure trove of gold coins and jewelry. The city, built around a grand temple and crisscrossed by canals, was Egypt's premier international trading port before Alexandria. Its demise was dramatic. Around the end of the 2nd century BC, a powerful earthquake likely caused the unstable clay soil of the delta to liquefy, swallowing the entire metropolis into the sea where it lay hidden for 200 years. Finding these sites is one thing, but how do you accurately record a complex, three-dimensional site in an environment with currents and limited visibility? The answer is a revolutionary technique called 3D photogrammetry. It involves capturing hundreds or even thousands of high-resolution, overlapping digital images of a site from multiple angles. This can be done by a diver meticulously swimming a grid pattern or by an ROV. These images are then fed into specialized software that identifies common points and triangulates their positions to build a dense point cloud. This is then converted into a realistic, fully navigable 3D model of the wreck or city. This technology was used to unlock the secrets of Pavlopetri, off the coast of southern Greece. Lying in just 4 meters of water, Pavlopetri is the oldest known complete sunken city in the world, stretching back over 5,000 years. While early surveys provided a basic hand-drawn plan, a project starting in 2009 used a sophisticated robotic survey instrument to create a highly accurate, three-dimensional digital reconstruction of the entire city. The results were astonishing. The survey not only documented the known buildings with incredible precision, but also uncovered over 9,000 square meters of new structures, revealing a flourishing port city that thrived for some 2,000 years during the Bronze Age. It had a clear urban plan, with residential neighborhoods, administrative buildings, and a bustling harbor. This discovery pushes back the history of complex urban planning 1,000 years before the Golden Age of Athens. Not all submerged sites were lost to disaster or the slow creep of time. Some, like the magnificent harbor of Caesarea Maritima on the coast of modern-day Israel, were victims of their own ambitious design. Built by Herod the Great between 22 and 10 BCE, it was the largest artificial harbor constructed in the open sea at that time, built on a straight, sandy shore with no natural protection. Herod's engineers pioneered the use of a revolutionary material, hydraulic concrete. By mixing lime, sand, and a special volcanic ash from Italy, they created a concrete that could set and harden underwater. Underwater excavations revealed the remains of giant wooden forms that were floated into position, then filled with the concrete and intentionally sunk to the seafloor, creating massive blocks that formed the foundation of 2 huge breakwaters. The sunken ruins of Caesarea are a testament to an ancient engineering prowess that was unrivaled for centuries. But we can go even further back in time, to a drowned Stone Age village. 9,000 years ago, a community thrived on the shores of the Mediterranean. This is Atlit Yam, discovered off the coast of Israel. Lying 8 to 12 meters beneath the waves, the site offers one of the most detailed portraits of a late Stone Age community ever found. The slow rise in sea levels after the last ice age covered it in a protective blanket of sand. Underwater excavations have revealed the foundations of stone-built houses, a 10-meter deep, stone-lined well, and an enigmatic circle of 7 massive stone monoliths arranged around a spring, perhaps for ritual purposes. The site provides the earliest known evidence for a society that combined farming with a heavy reliance on fishing. Tragically, the site also holds a darker secret. The skeletons of a woman and a child have revealed the earliest known cases of tuberculosis in human history, a poignant, personal story from the dawn of the Neolithic period. The future of marine archaeology is on the cusp of another leap forward. Researchers are developing artificial intelligence algorithms capable of automatically detecting potential archaeological sites within terabytes of sonar data, dramatically speeding up the discovery process. The next generation of underwater robots will be even more advanced. Robots like Ocean One are designed to work at extreme depths and have hands equipped with haptic feedback, allowing an archaeologist on the surface to feel what the robot is touching and handle fragile artifacts with human-like delicacy. And perhaps one of the most exciting new frontiers is the analysis of ancient DNA from underwater sites. Scientists can now extract DNA fragments from the inside of a 400-year-old clay jar from a shipwreck, revealing it once held oregano, olives, or wine. This technique offers the potential to understand ancient trade, diet, and agriculture with a specificity that was previously unimaginable. The sunken cities and lost harbors being unveiled by marine archaeology are more than just historical curiosities. They are vibrant, detailed chapters of our collective human story. The ruins of Thonis-Heracleion, the streets of Pavlopetri, the breakwaters of Caesarea, and the village of Atlat Yam all challenge our perceptions of the past. These discoveries are made possible by a remarkable synergy of science and technology. As this technology continues to evolve, we can only imagine what new wonders and what deeper understanding of our own past lie waiting in the silent depths. The greatest museum on Earth has only just begun to reveal its secrets. Thanks for listening to G Fun Facts Online.